Now that you have reviewed the design brief and listened to the designer videos, I'm going to give you an overview of creating the AutoCAD section of the team project, so that you can work with other designers as they create an urban park. The final 2D drawing that you can see consists of a site plan and other landscape features, including a 3D model brought in from Autodesk Maya. The key first step in terms of creating electronic drawings was the 2D site plan. I created a number of layers and then started to create that site plan and then distribute it to the other designers. And here we can see the images that I distributed. It consists of the overall sizes and some text, particularly the orientation of the urban park with reference to the north arrow. After distributing the 2D plan to the other designers, I then set about creating my own stages of my urban park design in AutoCAD. Let's look at some of those. If you recall, the theme here was to use the shoreline and the shape of the shoreline as a theme, and I'm doing that by creating a polyline that matches that particular shape. This will be used by the other designers in the sculpture. It's always important to use and reuse data, so with 3 other designers involved, I've brought in a 3D model from Autodesk Maya. It was brought in as a polygon mesh. Some other landscape features including a gabion wall, which is a wire mesh cage, and either gravel or in this case large rocks placed inside that cage. In the videos that follow, I will demonstrate how I created the drawing of the urban park using AutoCAD and then share data with the other designers.
Hi there, my name is Adam Crespi, and I'll be leading you through some exercises in Autodesk Revit to implement the designs laid out by our design team, landscape architect, artist, and so forth. In Revit, in an existing scene of the buildings provided, we'll add in a canopy, support poles, a serpentine bench made out of 4 centimeter diameter or 1.5 inch diameter steel pipe, and custom-made brackets to support the benches. Along the way, we'll look at techniques such as sweeping, blending, modeling in place, placing components, and other such pieces. In this first lesson, we're going to place structural columns for our canopy, the outline of which we can see here in blue. And these will also hold up the bench drawn here in red, this serpentine array of pipes. And we're going to use round pipe columns here. We'll go in under components, and it's actually a component or family we're going to place here. Structural columns, what we'll choose. And in this, we go to structural column, we drop down. The first thing we get are wide flange, and some available ones are maybe previously used and not quite what we'd like. And what I'd like to do then is up here I'd like to load a family to place. And I'll go down to structural in my families, and under columns here's steel, and in steel is a pipe column. And there's my 6-inch standard pipe is one we're going to use. What we'll do then is, for the brackets, make them a family, a custom-made family, that fits this column very nicely and allows us to place multiple brackets easily. I'll hit OK. And now my structural column, making sure it's a vertical column, I can zoom in and place these. I'm going to put one kind of right here up against the wall in kind of the swoop of the bench, and possibly another on line with it and next to, and then 2 more further down the wall, kind of following the humps of this line here a little bit to make sure that we have adequate support for our canopy. Just go ahead and place this. There we go. We can always move these afterwards, is the nice thing. It's never really set in stone. And this one I'm actually going to pull out from the wall quite a bit to hold up this bench and let there be a space behind it, because this canopy tends to swoop out pretty considerably. And I'll do one more here at the end of the bench, as the bench will curve down, and this will hold up this outer edge. So now I've got my columns in, and I'll go into a 3D view and see how they look. So I've gone into my standard 3D view here, And there's my columns all placed nicely down at 0. And we can see we'll have decking go around them, and there's the bench and the coastline sculpture and so forth. The really nice thing about these is if I go to modify and I choose multiple columns in here, holding control to select, and I do things like changing the top level or top offset or otherwise. In this case, let's make the top level level 2, and with no top offset, I'll hit apply. Those columns now size right up to level 2, and this is true for any object like this. And anything else I change with it, they'll take on those properties. So I'm going to make all of these for now. All of these columns I will select, and over in the properties I'm going to take off the top offset of whatever that is, zero that out, and their top level, I'll drop down and pick my level 2, and there's that offset gone. Okay, I had to do the level first, and I will hit apply. Giving me a minor, oh, there's my minor error. Yes, I'd like all of them to go up to level 2, and I'll hit apply. Now I'll take out all of their top offsets and apply. And they all jump back down. Sorry, I just did that in the wrong order. Good to illustrate, though. I'm really not set in stone here. It's very malleable, so don't be afraid to change things if they don't look right. That's perfectly fine to do to get the design right. In the next round, then, we've got the columns. We'll go in and place brackets once we've made them.
Now that you've reviewed the design brief and listened to the designer videos, I'm going to give you an overview of creating the Autodesk Inventor section of the team project so that you can design your own water feature and work with other designers. I started with the 2D layout from AutoCAD. When I was finished, I had created a water feature which starts at the back of the site and then works its way downwards. The profile of the water feature is shown here. Let's look at the finished model in Autodesk Inventor. I created this using the sweep command. To create the sweep, I need a path and a profile. The path was actually brought in from another designer, so let's look at that. It's actually a DXF file, drawing interchange format, and was brought into Inventor. I then saved that file as my new part file and continued on with creating the sweep. Here we see the sweep. So it's along that path that was brought in as a DXF, and the profile is the profile I showed you earlier on. Now, since there's only one profile and one path, Inventor automatically selected these and created the sweep feature. I'm just going to turn off the visibility of those sketches. Now the water goes from a higher elevation to a lower elevation, so we need to be able to move that water back upwards. I'm suggesting we use some sort of turbine to do that. So here's the water turbine that we're going to be using. It has a series of blades. Let's see how those blades were created. I actually used the sheet metal environment for this. And there's the profile created using the spline command of one of the blades. Looking at the feature itself, it's a contour flange. I selected the profile and then gave it a distance. To smooth off the corners and give it a better shape, I used a sketch and then extruded that sketch to remove the corners. In the videos that follow, I will demonstrate how I modeled the water feature and the turbine assembly using Autodesk Inventor, and also shared data with other designers.
Hi there, my name's Adam Crespi, and I'm an Autodesk Certification Evaluator in 3ds Max and Maya, and I can also run around in Revit and a few other programs nicely. I teach both in animation, game design, and interior design at the Art Institute. What I'm going to look at in this project is bringing assets from Revit, Inventor, and AutoCAD together in Maya with the purpose of taking them out to Unity to play the design. Along the way, we're going to look at project management, data management, scale, optimization of elements and textures, a little bit of mapping and material creation and application, and also good practices like naming, project setup, and so forth. In the end, we'll have the scene as you can see here. A gabion wall composed of wire cages filled with rock, a coastline sculpture with a waterway, a kinetic sculpture spilling down the side of a building, a water sculpture on the coastline, and also a very freeform canopy with supports and a bench constructed of steel pipes. The idea then is we're going to build an urban park, an oasis in the middle of the city, as a bit of a refuge, and use the techniques here for visualizing the design and stepping through it from a person's perspective. So, for the first round, we're off to Revit. We're going to take the existing buildings and look at some quick techniques to build new custom objects, and then export out to Maya and start to bring the other pieces in.